Starting off, we have the Johnny test. As you can see it below, we have the homing sequence first, started by a button. It stops, hits our point where we want to start. Our start button then goes. It the pump starts activating, spinning for 3,000 counts, stopping for the middle 2,000, and continuing on for the last 3,000 before finally stopping for the last 200 counts. Each time it stops, it reverses a little bit to suck it back in, and it does this back and forth for 2 times each way. The reason we're doing a delay between each side is it allows time for the user, the controller, whatever, to move the box ready to be the next section over.
Here we use the limit switches, traveling first to the left one and back to the other side, and then it will travel to the right limit switch and come back just to the other side of that one. And this motion is done in order to get our full travel distance for our actual sequence.
So in our actual homing sequence, we aren't going to both sides. We're going to the left one, triggering it at the 0 point, stopping out there, and then moving an additional 25 where we're ready to go.
Here we have our emergency stop button.
So now we're up to how reliable our system is. As you can see in this test, we are going to be running our entire program starting from 0 all the way to the end. At this point, you'll see on the screen that we hit the mark, we'll come back and eventually hit again. On both hits, we hit the same position on the dual indicator, showing that we are hitting and repeating the same movement over and over again.
Here we show a trapezoidal move using our H-bridge, and we utilize a PWM with a duty cycle of 37% to get that 1.2 amps. And here we have resonance around 200 steps per second.
Here we have our pump through our SCR3. We're using 1.2 amps and 200 microsteps. We have our velocity set at 300 steps per second and our acceleration at 500 steps per second squared. As you can see, it's trapezoidal, and it is also started by a start button.
Here we have our stepper motor at 200 steps per revolution, going a max speed of 250 steps per revolution, or steps per second, and acceleration of 200 steps per second squared. Now we will change the micro stepping to 2,000 steps per revolution, as well as increase the speed and acceleration settings by a factor of 10. One second.
Down there.
Upload.
We put in there like get the drawing.
Okay, so it should perform the same distance at the same acceleration and speed. However, with micro stepping, we're seeing a slower speed, and it is slightly smoother and quieter using micro steps. This is a micro step value of 200 with an acceleration of 200 steps per second squared and a max speed of 250 steps per second.
How many revolutions?
A total of 5 revolutions. And we're now changing the micro stepping to 2,000 steps and keeping the acceleration and speed settings. It is much slower, however it is much quieter and seems to be a smoother
profile.
Here we have our pump performance testing using a load of 423 grams and an experience as a stall. Here we have the performance testing of our stage implementation using a load of 1,319 grams. And to see more performance testing results, look at the end of this video.
So as you can see on this data, we've changed the microstepping size, we've changed the bus voltage from 36 volts to 17 volts, we've changed the current on the STR3, we've even changed the series and parallel of the wires. For all the results, please see the two tables listed on this page. Thank you.